So I'll just give a bit of background information, and that's basically, I was hired by Rasmus a year ago to actually do a research on crops, and then we had two projects. One was LiDAR and the other was the radar. And the idea was that we should be able to estimate biomass and other parameters from the crop based on the radar, also an amount of yields. But basically it turned out that when I was actually looking into this, I was actually finding a lot of different results that was interesting. So it ended up more being kind of exploratory because we didn't have any external reference data. One of the things you actually see a lot with remote sensing is that you can measure a lot of parameters, but you actually also need parameters from the field when we're talking agriculture, so you can actually correlate what you're doing to something. That could be moisture or crop parameters or something else. And that's actually a challenge. So I actually started to say, what can we actually use this radar for? And what can we, and the other Sentinel technologies from ESA, because they're free data. It's free data. And it turns out that you should, instead of saying, I want to use it for this, you should actually more look at what's the possibilities, and because there is a lot of advantages you can get out of this kind of system. So what we basically was trying to do here is that when you download data from ESA, it's very, you have to go through a lot of steps to actually handle your data. And if you research the articles you see out there, I had a hard time actually redoing the results they made because they were documenting half the steps they were doing. And if you found some kind of good result and you kind of want to reproduce it, then you had a problem because I couldn't get the same result because half of the steps were missing. So my idea here, and what I talked to Rasmus about, was actually having this kind of service where we have put in Denmark since 2006 all the data that was actually collected from the ESA satellites, and presenting them so you could actually download them as small GIS projects you could load in this instance in QGIS, but it doesn't matter if it was ArcGIS or some other tool. Because QGIS, for me, seems like a tool that a lot of agricultural researchers could use. I come from an engineering background, I know a lot about software and electronics, so I was trying to merge this gap. To just give an example here, this is the current homepage. I think I sent a link out with it, and the way it basically works right now is I could go in and say, okay, I would like to have the newest data for an area. We're going to make a video, and I'm going to get back to that, where I go in and say, I want to look at a specific area in Denmark. For example here, I go in and say select all. And then I just add my email. And I press submit. So now the system on the server is actually in the background, actually it already has the data pre-processed, but it actually is packing it together in a QGIS project where you have the newest data. In this case, it's for the last 14 days. The other option we have is to...
Was it only for 14 days? You said for...
Well, wait.
That
there's two options here, because you don't have to limit yourself. There's another option I also added here, is that if we know the crop type, or we want to look at all crop types, we have an external source that's the Danish database of all the fields that's actually registered out there, and the farmers go in and draw that kind of data. And that's another source we have. So if I want a specific crop for a season, I can go in the other tool and get that kind of data. It's two different approaches you want. You might want the newest data to go out and see what you have in the field right now, or you want the data from last year or the year before, because you have data you could correlate against. Mm-hmm. So that's kind of two different approaches to what you're seeing. Basically, one of the challenges I had was on my own computer. I don't have enough space for all of the data that's for Denmark for all of this period. I would need around 20 terabytes. and when we are working with this, you kind of switch place all the time, so I would need to delete the data and then recalculate it, and that takes 3-4 weeks to pre-process the whole season for a new area, and that's just too long. So that was why we created the server and said, okay, we can just put it up for free, because then everyone can use it. So just to give an example here again, that's basically an area we downloaded. And if you add the newest field info, you would actually be able to see that different fields. Oh, the coloring is not good in here. Can't we do something about this?
Det er jo ikke sådan en mørklæg, men det er desværre meget.
Oh crap. Prøv lige at skrue ned fra den anden side dernede. Det kan være, det hjælper, jeg ved det ikke.
Jeg kan også bare stå.
Jamen, jeg tror, det er dernede fra den igen. Okay, basically, we have 3 bands from this Sentinel 1 that I've actually color coded in, so it actually is visible, so you can see it. And it's very easy if you look at this and compare if this is this window read or some other crop. You can actually very easily see it. So it's an easy way to validate what you're seeing is the correct crop, because if you look at the reference data, then there's a very good visual correlation. An example I showed Rasmus, and that was basically why it can be relevant to just download the newest data because you want to go out and look at the field. Radar is an active sensor, so it sends a signal in and it actually gets its own response. So I actually showed him an example of an area where that was somewhat flat. All the lines here is half a meter in level difference. And if you zoom in on this specific field, I would not expect that the level height difference had the biggest impact on the response I got back. So what I would expect to see if I did some kind of clustering on the data I had in QGIS or some other software was, okay, where is the difference in this field? Where's the interesting part? Where should I go out and actually do samples? I had this discussion with Mogens actually at some point where he said this is actually what we want to use it for, because he saw it as a way to actually see where should I actually sample data to see if this kind of sensor could I correlate it to something instead of I had to sample the whole field. So that was one of the ideas. That would be what you could use for it for rapidly. Okay, if I had to go out and fly with a drone or something else, go in, download the data, you get the newest data from the server, and you have a choice to actually go out and sample based on that. And then you have the yearly hyper process one. That's the next step. So just a bit about remote sensing in general. A lot of the slides I have here, some of them I've grabbed from different places, and the reason I wanted to do this internally was I haven't had the source for all of them because I found them in forums and stuff like that, and I generally would like to give credit to people, but some of the times it was kind of hard to do in this case because they didn't write where to got the data from, but they're still kind of relevant. But it is water resources, moisture, and crops they kind of want to predict with these remote sensing systems. But what you actually need a lot of the time is either an article that explains to you this is how you can track this specific parameter, or this is the experiment we did, and you have all the steps. And we basically want to create a service where there was a well-documented way that you see, okay, how we got from A to B, and you didn't have to learn all of that. They did another survey here where they basically tried to see, okay, people are actually interested in looking at a lot of different parameters, and why not put the data free so we have it at a level so everyone can actually use it and find out what can we use the Sentinel radar data for. So what I basically looked into was basically saying, okay, what's interesting, and I came up with was currently doing Sentinel-1. The next step that I'm updating here Friday is that it's also adding in the valid Sentinel-2 stage, so you get all the relevant Sentinel-2 data, because that's another source you could actually use to correlate two different sensors. And it also has Sentinel-3, and the reason why that one is interesting is because it could actually measure surface temperature. And it measures it in 1 kilometer grids, but if you can get that for the whole of Denmark in 1 kilometer grids, that's still available information. Also on this homepage, I've collected a lot of the external pages where that's actually relevant for this. For example, soil data for a specific area, that's actually relevant to know weather data and all of that. So you don't have to go out and search for it yourself. I can collect the data because that's not legal for me to just go and grab the data from the DMI homepage. But I'm able to tell people, okay, you can check here and you can get to know how much rain did actually rain in this area for that specific date, and have that source to see if there's something that's interesting to look at. And also to say, yes, there is a lot of articles out there for just both soil and soil moisture. I've actually checked up on that because I know Mogens asked me about it and said, yes, that's a possibility. I haven't looked too much into it, but if I put the data out so you can use it, then you have the chance to correlate it against what you have. To get back to Sentinel-1 here, that's actually the main one. So radar backscatter crop, it doesn't just measure, for example, it doesn't measure height, or it doesn't measure one parameter. You kind of get a mixed response of a lot of different parameters from the system. And you have to have some kind of background knowledge about the field. For example, is there actually a crop on the field? Then it becomes harder to actually measure the soil. So you have to know what period you're actually looking for to sample for something specific. I'll send this presentation around afterwards because this one is just background information. But basically, when the radar signal is actually hitting the crop, it is also hitting the soil. So you actually get a combined signal back that you need to correlate against what you have. And you will also see different crops give different signals. And some would say, that's a bad thing, but that's actually quite good, because now you have the possibility to actually, for example, validate what the farmers put into the database. Did he actually plant winter wheat in this field, or is it actually rapeseed or something else that he actually planted on a field? Because we have the whole database for Denmark, and you would always be able to see the anomalous fields that doesn't match into that standard log database. And that's kind of specific for Denmark. I've seen it for Canada also, but specific for Denmark is that we have a lot of information about where we have crops, where they're planted for this season. So that's a kind of a nice data set to have compared to a lot of others. Yeah, the main thing they actually are using the radar for in a lot of the articles is to predict what kind of crop they are, because they have a sample set of small part of Holland or Germany, and then they try to predict the rest of Germany, what kind of crops they have in that area. We have the whole data set for Denmark, so we have a lot bigger data set we could actually dig into if that was interesting for somebody. And they are also packed into the QGIS projects that's on the server, so they are sent directly with you. Another factor that's biomass, water content is some of the ones, if we're talking radar in general. This is from a German, some German researchers back in the 90s who did a lot of research with planes and radar, but the theory is kind of the same. They just were able to do it once a month. and was able to do that for 5 or 10 years, and then was able to correlate the data based on that. So that was one of my sources to say, okay, what are we actually able to see in the field? I have some examples I'll get back to. Any questions so far? Good. So when we have these Sentinel satellites that's actually flying around, and you get this data in these QGIS projects, there is some metadata that's together with each scan, and you need to be aware of the time of day, if it's ascending or descending. I'll get back to what all of these means, because they are relevant for some of the measurements in terms of you shouldn't compare two scans that are too different from the same area, because then you won't get the correct results. You kind of need to correlate for satellite scans that are similar and not ones that are too different, because then you will get very strange results. And some of it is based on experience, in which cases you can do what. Then you have the satellite orbit. It's actually crossing Denmark a few times. And you have what kind of recording type. So there's polarization. It's not just sending down one signal, it's actually more microwave signals that send down. And you have incidence angles, and that one is, in some cases, very interesting. And when do we actually get a scan that's somewhat similar to the one we got last time? That's also kind of a very interesting factor. And then you have different backscatter conversions, and that's not something a lot of the articles I've read has been too good documenting what they actually did, because there's different versions. So just to explain in general, you have a satellite with a radar that's actually, it's not looking directly down, it's actually looking from the side and scanning. And that's why, as I say, there's an incidence angle. You're actually scanning a right area and getting measurements with an angle, and you need to be aware of that. So when you visualize it in your head, you need to be able to see that this huge beam you see here is actually the radar scanner. And the smaller the spot size you actually want, the smaller the area you want to measure, the bigger the antenna you need. So they are invertly correlated. So there's also why you today, from the Sentinel-1, you get grids that's 10 or 20 meters. They're actually not completely square, but you're actually converting them so they become square pixels, because that's so much easier to work with in QGIS than any other project.
So this also will have an impact when you look at hedges and trees, these transitions between the fields?
Yes. Ascending versus descending. That one is kind of easy to explain, because the satellite is circling around, so if it goes from either north to south, that's ascending versus descending. And that also means that you're kind of looking on a field or trees from two different angles. Then you actually are getting two different measurements if you're looking at the same forest or the same field. If it's soil and it's somewhat flat, or it's water, it doesn't matter that much, based on my experience. There are some other factors that's relevant there. Just to give you an idea, and I know it takes a few minutes, but this is what the satellite is recording in one day. And it takes 2 or 3 minutes, but just to give you an idea of the amount of data they have up there.
It looks a little chaotic.
It looks very chaotic, but they have actually a very, very planned route for this. And some might wonder why it's not recording everywhere. Some of it, it's a lot of data that's recording, so it also needs to kind of transmit it down at some point. And the other is that there's agreements for where we need to record and stuff like that in the system. Basically, it just continues and continues and continues. But basically, the revisit time is 12 days, so you'll first it would pass for the same track. It will actually take 12 days, and it has 172, 72 or 75, I can't remember. So it's in one of the next slides where it's actually running these recordings.
Is that going to change with the so that now you have Sentinel 1, but Sentinel 2 and 3, do they also have a radar?
They don't have radar, but they also have orbit tracks where they are circling around, and they are circling around a lot of tracks each day. They are using...
But you have a Sentinel 1A and B.
Yeah. Those two is actually in polar opposites. So one is doing ascending orbit, the other one is doing a descending orbit, and they are trying to be 180 degrees. They are trying to do that very, very precisely. Basically, when they revisit the same place, they're actually trying to ensure that the satellites are within 50 meters. And that's kind of impressive in my head, that you have something that's flying around up in orbit and is actually ensuring that it's trying to make the same recording 12 days later within that small margin, and so you can actually recompare your data. And also to see that those are actually the tracks that it's going around, and that's why it seems so chaotic when you're looking at it. This is actually the areas where it's actually recording, and if you look at it, you will see that Denmark is, and most of Europe is actually the place that's mostly covered with this. That's the main place where it's having a lot of revisits, and also the place where it's has most scans is in the regions closest to the polar regions. This map is quite relevant to look at because, as you see, it's not the same number of scans you get for each place in the world. There's other satellites. There's 3 actually. There's another one, but there's one that's actually never visited in Denmark, as I have found out. There's a Korean or Japanese one, I think, and that one might be interesting for somebody who wants to look at Australia, for example. But just to give you an idea of the number of tracks, this is England, that you see either in ascending or descending mode. There is actually a number of scans that is actually intending to do for the whole of England. And you kind of collect those. I've not chosen in terms of Denmark to stitch these together, because if 2 scans is taken with 2 days in between, then you have the area where you need to stitch them, and then that can kind of get strange if you want to measure crops. So that's one of the things I've avoided. I just keeps them in the current ones and then just extracts areas for the area the researcher wants to look at.
So the sweep of the radar is not able to cover Denmark in just one orbit?
Nope.
No.
This is Denmark, and this is the sweeps.
Yeah.
So you're actually seeing tracks that's going around that way, and you're seeing tracks that are going that way. That's actually, this is just, when you go into the server, you basically request the raw data. It's not been processed, but this is basically what I do on the server, and packs them into small projects. You don't get all of them, you get a recording like this one, and then you're missing half of Sjælland, but you get that a day later or in the next one where it passes by. Also, something that's interesting is this example. Sometimes to throw out data, you see there's 2 bell-coupled paths here, but sometimes there's actually a scan that's missing when I don't download the data, and that's sometimes because the data was so bad that they just concluded out. That's part of the process. So sometimes there's that data missing. And you would also see there's, if you do the same analysis for this part of Denmark and the top of Denmark, you will see that you get a different number of points if you look at it over a whole year, because there is different number of samples where they have a valid scan I could use in the processing I'm using. You could actually download the raw data and try to fix that, but I think it would need a few years to that, and that's not relevant. It's more interesting that we're able to get so much data from the same areas constantly. basically you can you have a revisit time where you actually scan the same area in the same way with 12 days in between, but there's actually scans for the same area normally with the way they have it now with 2 satellites with 2 to 3 days in between. And that's pretty nice if you actually look at it and is able to work with the data.
What makes a scan valid? Is it valid?
There is, I think they have both. They have some criteria internally in terms of there is actually on the front page there is actually a sample. We see there is a square area out in the water where it looks very strange. And I think based on what I've read, some of those scans, if that's for too huge an area, you just throw it out. They also have a lot of other checks internally, but I haven't dig too much into those, what they actually are.
Yeah.
Again, just an example of
what kind of atmospheric conditions can have an influence on the radar?
None.
Not electromagnetic.
Maybe there are some very extreme cases, but that's basically the idea that it shouldn't be the part that's actually impacting.
I think I heard really heavy rain can have.
Yeah, but that's the rain that's gone onto the ground, because that's kind of the. I'll get that one in a few slides. But also again to show the coverage that you have for and the revisit time is actually very different for the different areas, and they are sampling in different ways. The main focus of all the Sentinel satellites is actually climate monitoring. So that was actually their goal, to actually monitor how the climate and how impact on the climate is actually impacting it. We're just using the free data for something else. So they have made a lot of decisions based on their main focus, but we are just taking the free data and trying to use it for our purpose. Then you have polarization, and this is just in general for radars. You have horizontal and vertical polarizations, and that means that you can have 4 kinds in total. That's the raw data that you get from, in general, all the synthetic radar, aperture radars, satellites, but you have to check because not all of them are scanning the same. Some are scanning all of them and are doing huge areas. Some, like the Sentinel, is actually not scanning all of them over the same areas, but switching between modes, and that's pretty annoying. So if you look at research from the 90s, where they say, we have them all, and you get the Sentinel satellite saying, well, in Denmark you can get those two constantly. That's also a challenge that you have to be aware of. And basically, because you have this vertical and horizontal scan that's hidden different crops and also have the mix in between, you will get different responses on crops and soil and whatever your data is actually hitting. If it could be a city also, you would get different responses, and that's why you actually have these 4 main bands in general when you're talking about synthetic aperture radar that's relevant for what you're working on. You would also see some articles, and I've just mentioned that also have right and left polarization. That's nothing to do with the Sentinel one, but it's still relevant to know if you're reading an article that they actually have another option to actually twist it to go in both the one and the other direction. And they can actually extract a lot more data if they also have that source compared to without it. But I've only seen that one for planes until now. I'm just mentioning it if you're looking at an article. So that also means that you have different versions of this. They can create different kinds of images that look, they measure the kind of the same area, but the look, as you see, is quite different. And you also have to check what did they, if you take an article, what did they actually do in the article? Why did you get that response, and what kind of data source did they use? Can I reproduce this? And that's been one of my challenges in this.
But in that picture, did it matter at all? I mean, all the contours and...
The contours are there, but I'll get back to if you, for example, have a crop where, and if it's horizontal or vertical, there's actually, depending on the crop, you would actually get very, very different responses, depending on that. And that's basically what I'm trying to say with that slide. And here is the bucket that's been challenging me, because the horizontal and the horizontal vertical signals is the one they're only using in the polar regions. And that's the ones that's the best for yield estimates.
That was where Martin, he really disappointed me.
Me and Rasmus had a very long discussion, because the way when they started this up with the Sentinel program, they just recorded data, but they also did experiments all over the place, where they just tried to switch between the nodes and do experiments like that. So when I downloaded data from 2016, there was all 4 polarizations available. I was like, whoa, that's nice. And then I found out, oh, that's not what they're planning to do. This is the future. This is the way they're going to log it. So you will only see, in this case, you will see for Denmark and most of Europe, you will see that you have VV vertical and vertical plus vertical horizontal. And for the polar regions, the ones that will be the most interesting for yield estimates based on literature, they are actually not constantly present. They're only doing experiments with that, but also if an emergency, some natural catastrophe is happening, they're actually switching back and doing all bands, so they can do it. They're just not doing it constantly, and that's one of the challenges we have. That doesn't mean you can't use the Sentinel radar for anything, it just means that it's a challenge to go that way. Me and Rasmus had this huge battle where he said, yeah, but if you have this data, then you can estimate the yield. Yes, but we don't have that data. Sorry. Then you have another thing, and that's basically, because the satellite is at an angle, you also have an incidence angle when you hit the ground, and you need to be aware of that, depending on the sweep. That's also in the metadata. What was the angle when we started the sweep, and what was the angle when we ended the sweep? That's also a relevant parameter in your system. In some cases it doesn't matter. So you have parameters you sometimes need to be aware of, and sometimes they doesn't matter at all for what you're looking at. And that's the hard part. A good example here is actually, they measured the water bodies with the Sentinel satellite, and they had VV and VH polarization to see the incidence angle. If you assume water bodies is somewhat constant, there is an impact on the measurement response you get back. You would also see in some of the data you get from me, if you take from our server, if you take a very huge area and you see water, and then you see at some point the water is actually areas changing color. That's why. But you just need to be aware of what the angle is at that specific point that you want to look at. Then we have the beta, sigma, and gamma backscatter. Basically the one that you see in most articles, that if they haven't written it, then you should assume that it's sigma backscatter. And basically it's just 3 different ways to measure the same thing. I've worked with the sigma one and the gamma one. The gamma one is you generally use that if you have very steep areas. You want to compensate for the terrain. You can convert to that measurement rate, so then you can compensate for the terrain. So sometimes you just in an article write, we use VV. Yes, but this is also kind of interesting. Did you compensate for terrain or not? I kind of need to be able to redo your results to actually validate that what you did was actually something I can use for something else. And if I can't do that, you can see already with the number of combinations you have, then it becomes quite hard if you don't document what you did. How did you actually do it? And that's one of the things we try now to actually cover here. Just to tell, again, the Sentinel A1 is actually have this 12-day revisiting time, but also there is different kinds of radars. One that's running X-band, and some that's running L-band, and like the Sentinel one says, run C-band. That's also a parameter. If you find an article, you have to check what kind of band that article was from. It doesn't matter if it was plain, because they can make assumptions that you might not be able to do for the Sentinel satellites. Again, it's a parameter you need to be aware of. Also, just to see what kind of different satellites that's available and what's coming. I'll get that one again. Also to show different kinds of X-SEEP and L-band give different responses on different kinds of surfaces. They, in terms of snow, that's actually the very good one, they are penetrating at different levels. So if you really want to use these remote sensing systems, some of the good articles, they actually have all three bands in the overflies they're doing. They're first overflying with one band and then the next and the next to get a whole area, and then they analyze it, because then they have a lot of more ways to do tricks. But in our case, we only have the C-band. It's just to tell that if you find an article, you need to check what they're actually doing in the article. What kind of band is this synthetic obturator? If it writes Sentinel-1, then you kind of know it, but it could be one of the commercial ones that's out there. And sometimes you want to redo the results with the Sentinel satellite to see if it actually still works. So just to give some examples of the same area here again, water has an impact on how the signal is transmitted back. And that actually, if there is a lot of moisture and there's a lot of water in an area, it will impact the response that we get back from the satellite. Or basically, so the map would actually change if it's been heavy rain for an area. I'll actually show an example of that. And also, the height of the crop is something that we can actually measure somewhat. That's one of the parameters. Indian researchers have been very good at. They actually only getting the VV one, but they're able to measure height, leaf area index, and a lot of other crop parameters and soil parameters based on there. They're not so good at documenting what they're doing. I think it's because they have some commercial partners that's not interested and they document everything they're doing, but they're actually able to, a high degree, actually estimate what level their crops are at. They have taken NASA and ESA satellite data from the Sentinel-3 and another weather satellite from NASA, and they actually, on a very high level, able to predict what the weather conditions are based on that. And they had a number of years with the catastrophes with winterweed, but they use the satellite system now as a commercial source from the government to predict who should actually get paid because there was a catastrophe based on that. They actually make a guesstimate, very good guesstimate, based on what I can see, on who should get paid or not. Because if somebody applies, they could just claim that they lost a lot of crops. But that's not always the case. And they use that access as a way to validate what they're doing. I could see you could do something similar in Denmark for just different crop types. Did he actually show what he claimed on his field? Or is there something strange going on? Because you actually have the database, they have to put data into that you can actually check up against.
Leaf area index.
Yeah.
That is the amount of, if you have a plant and you put all the leaves together around you.
Yes.
On a square meter, then you will find out that the leaf area index is 40. That means it covers 40% of this 1 square meter.
Yes.
Of soil. How do you measure that with a?
The trick is if the more dense for example, winterweed is, yeah, the less signal can penetrate through to the ground.
Well, how can you see on the? The way they did
it is they took measurements from India, and they basically, because labor is so cheap, they actually got a lot of samples from the whole area, and that way made a correlation between what's actually going on, and that way they were able to predict based on their estimate what the rest of it. That's one of the challenges I have. I'm missing the reference data. Yeah. We have one reference data source, and that's the crop database, and that's very unique, as I said, for Denmark. I've seen it for Canada, but I've not seen it any place else. They might be available, but they normally in the local language, so I might have missed it.
But you don't have anything about leaf area index, that it's not something that you get from machines or from the farmers, it's something that you go out and you actually do some...
That's actually what they
that's what
they did spot samples all over India. Yes.
Uh-huh.
I was a bit surprised, and I had the discussion with Rasmus, and that was also why I made this the presentation from the start. Maybe we should, you could use this as a way to actually see where's the difference in a field. Go out and check, does that difference actually correlate to something in the field? I have some examples where I actually did something similar myself, because when I started the project out, it was like, okay, if we don't have any data, then I just try to go out and grab something so we find out where we can actually learn from this. Again, there is a number of other options. There is 2 satellites that I think one should look into if one is in Holland for their case. Also, besides the Sentinel-1, that's the Atlas-2. I think that's Japanese, because if they want to look at Australia, that one would actually cover that, to solve that problem for them. They can use the same models, but they can use some of the same theory for this, and it's much better because it has all 4 bands. Then there is, I think it's Korean, this one, compared to the Sentinel-1, it has a resolution that's nearly sub-meter. But it is commercial and you have to pay for it. But they are doing a lot of scans, and it's very nice. I found one sample set from it where they actually showed what they could do with it, and based on the literature, that was very, very, very nice, but the price is high. So you either need to have a lot of money or make some kind of deal with them. There is also a number of the RadarSat program is actually a German one, and that one is actually also interesting because you can, as a research institution, make a deal with them so you don't have to pay, based on my understanding. But I think the process was so long, I was guesstimating 5-6 months, so I was saying I'm not going to use it because I don't have the time for it currently. That's just the process to get accepted. And you should kind of have a goal with what you're doing. So just to sum this up, if you are looking into the literature, check what kind of bands they use, check the polarization parameters they're using to correlate something. It could be NDVI, biomass, yield, it doesn't matter. If they make an assumption, it could be completely valid. But you need, if you just the Sentinel satellite, you kind of need, you're kind of limited to what we have from that one. And what kind of post-processing method did they use, did they document it? Because sometimes it's very unclear what they actually did. They just present the results, but I think it's very, very important that you can actually redo the results to actually get this kind of emerging scientific truth about this is actually working. I could actually validate this result and say, oh, I got something different. Why did I get something different? And you can actually also publish that because well, these differences is also kind of important. Okay, before I go to the Sentinel-2, I will show a few examples. So, until now, I just talked about all the parameters that you kind of need to be aware of if you just compare different scans. One of the things I noticed when I put this up was that people had a tendency, if I was not the researcher, but people had a tendency that they kind of want to look at a small part of the field. We are talking big data here. So if you want to research something, it makes sense, for example, if I want to look at this windowy field, it also makes sense to actually look at all the different windowy fields around me to actually see if this is a normal field or not a normal field, or what we're actually looking at. all these boundaries is also a very good source for just if you wanted to measure soil. Still, if you know there's no crop on it, you still know where the boundaries of a specific field is. So this is basically the server that's actually running up there. This is just my computer version of it. These are some of my current projects that I've just generated on my own computer, but still, if I open one of these, it takes a bit of time. The challenge is here that I ask for a whole season, and when I write all up here, it just means that I get it from the 1st of January to the last of December for all of that year. I don't know what kind of crop it is. If, for example, if it's winter wheat, I kind of need to have an earlier period. If it's maize, there's also a period where they actually grow and harvesting. I've added that to the system. Yeah.
So the different colors here is showing the different height.
Nope. It's showing the different processed responses, and if you want to correlate it to get to height, yes, you can do that. It's not measuring something specific, but if you have I'll actually show it this way instead.
So it's actually just a difference in the radar.
Yeah, it's the radar backscatter process.
Yeah.
You need to put it through, you need to fill out noise and a lot of steps that you need to do. And it doesn't make sense to have an agronomist sitting down and learning signal processing to doing this.
Because my question is actually, if you will want the height here, then this area over here is perhaps 2 meters lower compared to this area here in a geographical point of view.
But
how is it geo-referenced?
There's two options for what you're talking about. There is one where ESA is constantly building a digital elevation model for all of the world, constantly for all the areas they are scanning.
Yeah.
You are able to use that model to compensate for height based on that, and kind of normalize it.
Yeah.
But in their view, Denmark is flat compared to.
No.
Yeah, again, compared to. I know we have that discussion a few times before, but compared to if you look at India, places you have the Himalayas or mountain regions, but you can still do it. The problem is.
So it's actually like with the GPS, you have a kind of an ellipsoid, and then you have your own locally elevation.
I'll just go to show this example actually, because this one is actually. So basically, what I'm asking for now is that I have gotten all the field shapes, but now I actually just asking for if the crop is winter wheat. It's just a Danish name for it, but. If you go into the database and select I only want winter wheat, then you get the Danish name for, and then you can kind of figure it out. If I press this now, then I don't get all of them. But if you actually look at the result now, you see that all the winter wheat fields are looking quite similar. They're not completely similar, but as you saw before, there was a lot of other crops in between. But it's very, very visible that this is winter wheat. At this time of the year, I can actually go and see. Rapeseed is another one. It has a very, very specific pattern. I can see it all the time when you're actually looking at a scan. There you have winter wheat, or there you have rapeseed.
So this area over here is wetland, isn't it?
Yes, there is.
Which is also some bluish.
They have some. We can actually let it go back because then it's easier to look at for you.
So what time of the year was this?
It actually says on the side.
Yeah, I didn't know.
It says in all of the scans, it says specifically the date and the time. And if we go down, the one I've selected right now.
Yeah. what does it say? It's 17 og så 14 April.
Yeah.
So it's in May, yeah.
Yeah.
Where the winter wheat crops.
So we're basically measuring both the structure of soil and crop for these areas. And that's why we get different responses for depending on the different crops. If it has been raining heavily for an area, you would actually see, because the way I've coded the VV and the VH bands, that they are the red and the green one here. But I found an old German article that said if you combine them in this way, then you are able to measure water in a very good way. And that way I've mixed them together early in the processing stage, and that's why the blue one is actually somewhat representing water here. So it actually gets a blue color.
Yeah.
And that's one of the things that when we are publishing this and actually documenting the process we're doing it, then we actually put this in to just remember how it's done. Because that's also a relevant factor. So that's why you have all three bands. That's where the last band is coming from.
Do you know that this yellow field over to the right, this very yellow one over there?
Please go up and point.
This do you know what this field is?
Yes.
What crop is on this field?
Probably
going to be on this crop. On this field.
Let's see.
I think that wasn't that a forest?
Yep, it is a forest. There's no field there.
No.
That is actually the one thing that's actually interesting, because forest and reps tend to look somewhat similar in their structure. I have an example I can show. For example, here I can get to know what kind of field we have window reps.
Yeah.
And you see it has this dotted pattern inside it. I could take another example from here, just to...
No, it's okay. Now you have shown how we can play around with this.
Yeah, but
So.
anyway, it was just a way to kind of put this into... in the filing here, it's not clear all the metadata I talked about, the track and all of that. QGIS has a problem in terms of what I think is, if you have time temporal visualization of something where you have a lot of meta parameters to actually visualize it. I'm not sure if ArcGIS is able to do it in a good way, but if I have like 300 or 400 layers here, then it seems to be like a problem if I kind of want to search it and fill out specific layers for a specific problem. But
it's very rare that you have 230 layers
but
in a GIS project, I would say.
Yeah, but that's kind of the future. We're kind of moving towards now that we have so much data. Just to show, this is basically the TIFF or GeoTIFF file. Besides each GeoTIFF file, is all the metadata from the satellite, so you get the track data and all of that. I have not been able to find a very good way to put it into QGIS. I could write a plugin, but when I started experimenting with that, it turns out there's sometimes problems with different versions, and I kind of want to do something here that actually works for everything. I don't want to say that you need to run on this specific computer and run with this specific system, because that kind of loses the sense. So if you want to analyze based on that data, you kind of need to be able to write a bit of code to process based on that, or go into the metadata and open it. It's just an XML format where they put everything in, and you can open it in a browser, or that's another example here. Oh, come on.
Passionsfrugt, det har vi sgu ikke i Danmark.
It was actually it was actually a pass. Basically, if I go in this file and I'll just open and text it. So it's easier. I know I'm running a Linux operating system, but all of this also works in Windows, so there shouldn't be any problem. But just to show. I can go in this file and see here, it's called the pass, which way did it pass, and I get to know it was an ascending mode, or the two options are ascending and descending. And all of the metadata is in there. I haven't thrown anything out. Also, the incident angle from start to end is in there, and all of the other recording information. I haven't mentioned some of. There's actually a lot of parameters. I think there is. Yeah, but those the ones I mentioned is the ones that's relevant to look at for this case. There's some other ones for when they kind of want to stack layers on top of each other. Ja, kan I også?
Nej!
Ja.
Hvad trykker du på det her? Nu har vi siddet her og lige på øjnene sammen.
Oh, fuck. Okay, now we solved the problem. I will send the first presentation around, so but you kind of get the idea. So all the metadata is in here. I don't use all of them. I just going to give a few examples. So if we go back to my presentation, an example here could be all these dotted areas, as I said before, is actually winter rapeseed. So this is a winter rapeseed, and this is a winter rapeseed. I think that one's actually from Flaglia. Because I asked René, why is it looking like that? Is there something? I don't know. I'm not an agronomist, so I don't have that experience. But it was very easy to see the winter wheat and the winter rapeseeds. Those two crops, you can spot them in any scan. After they just gotten a bit high, then you can kind of they have this very peculiar structure. It's very easy to see.
Also in May, where everything is green, 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 green.
It's not.
In May you can do it.
It's not as distinguished as it.
Okay.
But here's the problem. You asked before about the level, if you have the digital elevation model. What I've seen is if I normalize, so the levels become even, that kind of pattern in the winter rapeseed diminishes a lot.
Yeah.
So you kind of lose data if you're trying to do one. So one of the next steps is here to actually have the two options. So you can actually look at both of them and see what's the best for me right now. Because if you're calling cosinus and sinus functions a lot, you kind of know if you're trying to do the inverse, you sometimes have multiple options. So if you're processing data, you're kind of in this way losing information. And so that you can recreate. So we kind of want all 6 options actually in this case, and create more bands. And QGIS is more like, it's good to have RGB images. If I have more bands, then you need to have a big understanding of it. And I tried to keep this so simple so any researchers didn't have too much of a background could actually really use it. But just to tell that the data is in there. This is one of the examples that I did. I'm sorry if my terminology is wrong in terms of that, but close to where I'm living, there was 4 winter wheat fields, and there was a number of articles that actually claimed that you could see this kind of rocking where the crop is collapsing. And 2 of the fields was actually very nice to look at, and there was 2 that was pretty much collapsed a lot of the places. So that was actually a kind of good sampling base to just check if this is valid. I was actually running around with a measuring pin to actually measure how the height of the crop in those areas to get some data. But I also recorded a lot of pictures. So what I actually did was before they harvested any of these, I just went back to see how the fields was 3 weeks before they actually started the harvesting. And this field and this field was the one that actually was having a lot of fletching. And if I analyzed it a bit more, this one actually also had it the way you see here. I didn't record images of that, but these 2 actually did record images of. So it became quite visible. You could actually detect that you had a field where this was happening before you actually went out and harvested it. And to me, that's actually valuable information. I'm not sure how the farmers could use it, but if you had very big fields and you had areas where that was happening, you could plan around them, in my point of view.
If you have lodging, often will have something with the quality.
Yeah, exactly.
Yes.
Yeah. And higher moisture.
Yes, based on what I've written, I read up on, I found a very nice one, I think it was 2 or 3 weeks ago, I found a reference data set to somebody had actually played a bit of engineering crops and put all the graphs that have been missing and at what stage would it collapse and so the kind of data have been missing all the time, so it was like, whoa! And based on that, I'll get back to it, I actually learned a lot. Here's another example. I had this discussion with Michael about if you could detect water, and also had it with Rasmus, if it had been raining heavily for an area. And I've been living from this area, I've been living 800 meters from here, and I know that area was always getting flooded each year when there was heavy rain. So what I actually went in and checked, and this is not looking at ascending or descending or anything, it's just a continuous scan for a period. You were actually able to see that there was a lot of water and it was kind of diminishing over time. I don't know why the last one is missing, but anyway, the water that was actually present is actually diminishing over the next 2 weeks. And that was actually something that you were able to track with this system. There's somebody who's been doing it in Holland, and he was a master student, and one of the things that he actually wrote in his proposal that he was able to do it some of the time, but if you look at the samples where he was not able to do it, they were so small. We are talking something that was smaller than 10 by 10 meters. And then if you only have 1 pixel, or 1 or 2 pixels, then it becomes hard for the radar to distinguish something like that, because then it more looks like noise and then it gets cancelled out in the processing. So you need to have areas that's larger than 10, you need to have 20 or 20 by 20 or 40 by 40, that's kind of the level you kind of need to have it at before the Sentinel satellite makes sense to do this kind of tracking. That was what I noticed. I'm not sure I'm completely right, but based on, I found this example and a few others where you basically see this process going on. And just to validate, this is actually a lake that's just beside it. But it's very visible in this. The next level that we're actually putting up here is to actually try to process the data a bit more for people, and you just don't get it into cookies. But this is more, so if you have a specific farm and you want to see, here's a specific field and I want to have the time, this kind of time analysis, because I was not able to do the cookies, then I just, I can generate a report for a specific farmer and you can see the kind of tendencies over the year. So this is a winter-wheat field, and the reason the sampling area is the green one in here, and I'm just taking samples from the whole field because in this case I just want to see the general tendency. It's just an example because how does this actually look for the whole season? The reason I'm not going too close to the borders is this is something that somebody has drawn manually. The second part is you have pixels that's 10 by 10 meters, but they are aligning where this pixel is correlated based on a 10 by 10 meter model. So we have, in my view, 20 meter uncertainty in that way, and plus I have the farmer on the other end that I don't know how precise he is, plus we might have trees on the border, so we're not that interested in this case on the border ones because it could be noisy. We're more interested in the bigger fields and inside the field. And that's also why all the red ones here, they are so small. When I started doing my analysis, I just said, we're not looking at those right now. We're more interested in the bigger fields because we're interested in seeing what kind of tendencies in the big fields are they kind of the same. What can we actually find with this kind of data? So we have the tree bands, as you saw in the key cookies project, and I basically just took the samples you saw before and took the mean value for each sample, and you have.
And the tree bands is also the combination of the color.
Yes.
When you look at it in QGIS.
Yes. And for each band I made a plot like this, and basically what I did is that I divided them up into ascending and descending, and actually for each satellite in this case, it shouldn't actually matter to if it was from satellite A or B, but I just tried it, just an example to show you kind of need the metadata depending on what you're looking for to filter out noise, because there is, as you see, this line is actually kind of having a better tendency compared to if I kind of mixed it all together, then it would be kind of like a very, very noisy signal. So you're kind of using this kind of metadata to sorting what set should actually be part of. So this is for the whole growing season for this field, and we have for all three bands that you're seeing what kind of tendency that you have. This is for 2017, and that's why you also have two satellites. If you go 2016, you only have one Sentinel satellite. In the future, there will actually be more Sentinel satellites. I think that they are talking about having 4 or 5, can't remember in all. Then you're actually getting a continual high rate of data that you could use. I will also get a bit back to what you could actually learn based on these kind of graphs, but it's just to show how you can actually measure a whole field and actually see how the progress is growing over a season. This is for Rinder Rape, I'm not sure about the pronunciation, just to show that the signal response you will see over the season is actually very, very different compared to so you kind of need to know what's on the field when you make this kind of analysis, because if you kind of compare two different crops, yes, you will see two very, very different tendencies. And you will, or it could be soil or something else, like you have a mudslide. If it's different conditions in terms of soil or something else, you would kind of also expect it to be different responses that you can't completely make similar. You kind of see the tendencies could be the same, but it doesn't mean they are. And another, again, for the tree bands. So when you correlate something for a specific crop, you're kind of making a model to predict a specific crop's response, not every crop. It's for example, estimating the height for winter wheat, because you have sample data to do that based on, or it's measuring the leaf area index for the winter rape or some other crop. So you need to have this kind of information to use the data correctly. Another example, and as you see, some of the signals have a very good tendency, and some of them is just very noisy. But that's also something that you learn. Should I sort out ascending modes? And in this case, I still combine the tracks. I could also start to filter out, so I only measured for the same track, actually filtering it a bit more. And then for this specific crop, that actually makes sense. It doesn't make as much sense for the winter wheat. So again, it's kind of an experience. We have to experiment with it and learn what makes sense. And I can't give this answer for every combination that's possible, because there are so many combinations.
Have you had the chance to just to have a look at the rapeseed field right now, here in January or in December, and compare the value on your y-axis to what you saw last year in the same period?
Not for the rapeseed, but for the winter wheat, yes. I have tried that one, and then I actually have a case.
No.
I actually have basically the reason why I did this specific field was that that's the next example. For 2016, I was able to find data reference that I could use to correlate. And then I had an idea of, will I, for the same field, if they actually shown, and it was for this specific field, down here, I haven't taken that part of it, but I was able to see the exact same tendency the year after, because they had shown window read on it.
And also the y-axis value.
Yes, it was the same. It was, okay, there was a percentage-wise difference, but it was the same. It was seeing the same tendencies. The response were somewhat hitting it was a bit delayed compared to 2016, but it was the same tendency.
It's more when we are talking about December and January and February.
Yep.
Typically, the field is.
The reason why I got interested in that area was this picture, and that's on the OnFarm homepage, because I was seeing a lot of lodging on that field. So I wrote to Birgitte, "Where did you take that picture?"
No, it's an experimental area.
Yeah, it's an experimental area. It's an experimental area.
Try out with fertilizer and make soil samples.
Yes, but she actually gave me coordinates for a field that was a bit lower than that. But I was able to figure out what that field, what that was, and it's this one, because you can see I can actually see where the lake is. The one she was sending me sample data for was from down here.
Yeah, okay.
But I was like, okay, then we have two different data sources, but you can actually see the same strange pattern in this one, and for the same season. If you go in and actually for 2016 and mark that area up and take a lot of window read fields, you will see that field is strange latency compared to other window read fields.
No.
It's if you really dig into the data and look at the VV band, that's very, very clear. I actually did a bit of analysis on that. I did basically, like before I did clustering of a field, where you basically, in ArcGIS, you have this iso-clustering, I think.
Yeah.
But I'm doing something similar, but it's just a different technique. It's called K-mean clustering. Anyway, it's removing, it's looking at areas that have the same tendency and clustering them together. And in this case, I'm putting in 5 clusters. And I think this was for the first band, and this was actually for the second band. So this field in general, if you look at it as a cluster, was actually, it didn't look the same way that all the other fields did. And that made it, for me, quite interesting, because it made it a way that I had another source to actually validate what I was seeing locally here in 2017 was actually the same tendency I was seeing in 2016, completely out of place in Denmark. That's the nice thing with this, that the data is there for all of Denmark. This was actually the trial that she had. And they were actually doing fertilizer, but that was for the field a bit further down.
No.
But what they actually logged for that one was the growth stage of the crop throughout the season when they did something. That was interesting for me. Because if I logged the events where they said, okay, this was at the level they noticed that the field was at, I was able to see there was some, or me and Rasmus were actually able to see there was some of the tendencies that was actually the same. And those tendencies was in, again for the 3 bands, this band was actually the most interesting one, because in this experiment they had 5 different fields, different places in Denmark for the same year. And then we kind of have broadened our experiment area, so we kind of checked that this is actually the same thing for all of Denmark. It doesn't just work on this specific field, it actually is the same. But for all of them, for this third band, they were topping around 59. Growth stage level 59. And I had no experience in doing agronomy research, so I was like, why is that? That's interesting, because we kind of been able to, when we are at level 25 to 24 to 26, it's starting to going up and having this tendency, and then it's gradually going downwards again until we have the harvest stage, and that's marked as a spot here. But it was the basic.
That was one of the first things I asked Martin to hunt down, because if we could set the clock for the different fields, we could support it with simulation models. We could adjust the simulation, say, okay, we don't need so much data from the farmer.
I'll send this to you because you can't read the axis down here right now, but just trust me that for all of, there was a few more, but it just makes sense to only show 4 of them. But for all of them, it was the same level that was actually starting to go downwards again, and it was the same level that was actually raising up. And that was to me interesting.
The harvest date, was that the exact harvest date, or was it?
That's one of the things that I asked Birgitte about, and I didn't get an answer that I understood. Because I was going into their log and trying to see what I got as the harvest date. I just and then I make
like it was very.
Yeah, I'll send you it
now. But
yeah, but basically my challenge was that I was like, okay, I have to make some assumptions. I'm trying to read this and understand it, and just put the data and see what we get. I might misunderstand what they intended with the process, and they could only have maybe harvested part of the field. But one assumption I can make is that if they sow in the field at the same time, the growth stage shouldn't differ that much over the field. That was my assumption. It could be wrong, but
I think it's the planned harvest date, and then the actual one you haven't got.
Okay.
Because what would be interesting here is to see the time from a growth stage here where it's actually having this peak, and say, is this actually the same difference in time here? Because then you can predict the harvest based on this data.
But how is it, Michael? Exactly with winter wheat, you have a wider span where you can harvest it without any damage compared to barley, for example.
Yeah, that's right. And
so that's the problem with winter wheat, that there is a span there where it's okay to harvest it.
well, at least you can say that based on a model here, based on this data, that can predict when the harvest is optimal or when the field is ready.
Yeah, I will go to. So I found this report, and it's from England, but it was basically because I had a hard time, and it's maybe not completely precise and not the best report in the world, but it was from when I was reading it, it was like, okay, this is an engineering manual, nice, because they were actually correlating data to something I could relate to. Okay, so the crop height, he was actually explaining how it would look like for England in this case, compared to the road stage. Okay, so 59 is actually the level where it's topping up. So maybe what we're seeing is that we're able to, between the low stages and until 59, we actually maybe be able to predict the height of the crop. That could be an assumption you could make based on what I've sampled so far, and also what I've seen in literature. So this was kind of results that you could kind of validate and see, okay, it actually makes sense. And it's kind of the same level they are topping out at. There was another graph that I found interesting is, he had in here, when we got to 39, it was the level where it based on how I'm reading these graphs, is that the crop was actually getting more biomass into it. Oh, that also makes sense, because now the crop has volume on the field, and that was the place where the graph was starting to go upwards.
But don't use it as an engineering standard.
No, I'm not using an engineering standard, but I'm trying to get an understanding here.
Yeah, that's good. Okay.
I'm trying to get an understanding, and I'm trying to get an understanding what should.
Because if you go into this sortinfo.dk, you will see these many different varieties of winter wheat, and then you will find that they are actually measuring the crop height for each of the variety of winter wheat.
Yeah, but Michael, the problem is, the problem is kind of asking a person for an answer, which is what is the general pattern of a growth, and I think this manual,
is the closest you get,
Yeah.
but
that guide is really valuable.
But don't use it as an engineering standard.
No, but I completely agree. But it's for my understanding, how do the crop actually develop? I don't expect that you have a winter wheat crop that actually is developing all of it as biomass at level 70.
And also,
There's a range. This graph was the most interesting one I found in the report. This is his green area index.
and if you remove the dates on the bottom, then I like this very much.
Yeah, but
I agree.
but it's just a tendency. But if you look at this tendency, his green area index, and you look at this graph, it's kind of the same tendency. It's fucking the same tendency. Sorry for my language, but I was like, what the? I can actually measure something, and it's actually for real. So you need reference data to actually correlate this to something to see if it's real. And this was a very valuable source that we actually had 5 experiments. They had 6, but they was thrown one of them out because they was determined that it was not as valid. The one I didn't present here was actually the one who was the most bad at logging the growth state. So he was the one who had the least samples, but for all the 4 others, the tendency was very clear. It had the same tendency in his set also, but
And what you have also shown here is that it's independent of, it's at the field scale level, so it's independent on the variability.
But it's from different places in Denmark. That was what I was like, it's very nice. And also, I think it was basically this trial, I could go in and see exactly the same tendency the year after on the exact same field. It was delayed, but it was a bit noisy. There was still like some of the numbers that was popping out and didn't match it. I'm sorry, I forgot to put the ascending descending, but the colors are actually the same for the first one, so you could be able to extrapolate based on that. I just forgot to put the legend in. The tendency was the same, and the level we were ending up at was the same. So for me, that was not completely proof, but it was evidence that it was a place that was worth digging more into. Continue to do it. I'm just giving some examples of what you could use this for, because the scene is kind of broad, and to see, okay, it's not just one thing, but it's multiple.
What would be of great value is that you can go in and say growth rate 32, you're around a certain value here.
Yes.
That would be of great value.
So
if you can say that over 3 years or more.
But I don't think you can say that if you assume it's a height. You cannot say that minus 14 dB is growth states, but because if the crop has been stressed in the growth, that will be shifted.
yes.
So you need to look at the pattern, the shape, how it's behaving over time.
The time
But you have this curve. No, sorry. Yeah, you have this curve from previous years, and then you are putting this new data coming in here. Maybe it's down here, the new data, but at least it's now going down, like over here. And then you can say on this model, it's a kind of a model.
You need to add the temporal dimension.
Yes. For example, if you actually knew what kind of winter wheat crop they had sown, and you had a lot of like the temperature and other information, you would and you had the reference data of how that crop would kind of progress. I think you would actually be able to predict a lot of parameters for that specific field. But you need we call it a remote sensing, where we are trying to collect a lot of data, but we also on the other side need a lot of data to achieve good results. It's not a magic tool. It needs reference data, and you either, as I've attended a few times, was trying to actually get external data, but a lot of the authors that you write to, they never respond. And that's the kind of the normal tendency. if you see a good result. I was writing to him, how did you do that specific part there? Because I was not able to reproduce it. Because there was missing parts in the article, or there was something, it looked very interesting, but I was not able to reproduce the result. I have an example of that actually a bit later on. Yep. That was the first part. So, oh come on. When we started this out, we actually had no reference data. So one of the things I talked to Rasmus about that we came up with was we have another reference source, and that's the Sentinel-2, and that one is taking images, a multispectral camera, and the literature on multispectral cameras and fields is very, very well documented. Could we use some of this data to actually predict parameters, then we could actually correlate that data to the Sentinel-1. That would be very nice.
And then just to recall, that's because you can't look through the clouds for that.
Yes,
okay.
yes. Just to sum up here, we actually have 13 bands on the Sentinel-2, and they are measuring a lot of different bands of the visual spectrum, but also outside the visual spectrum. What one should note here is that some of the bands it has a resolution of 60 meters, some has a resolution of 20 meters, and some have a resolution of 10 meters. Depends on the band, and you have to be aware of that. In the version I'll be putting up, I've resent all the bands to 10-meter grids. The reason I'm doing that is that it's so much easier to work with data that has the same grid size. And in this case, we're just going for the lowest denominator in terms of pixels, but if you're talking as 60 by 60 pixel, all the inner ones would kind of have the same value, but it's just so much easier to, if you want to extract 2 layers and do other factors like that. So, just to mention one thing, and that's why I'm also going to send this one around, was that inside the software you're using from ESA to process all your Sentinel-1, Sentinel-2 and Sentinel-3 data, there is factors that you can use to combine these Sentinel-2 bands to, for example, NDVI. If you know anything about crop, that's kind of a normal one to do. But there's also soil factors, for they have for the multispectral camera, that you can go in and look at. I'm just going to show them because I'm not into what they actually mean, what these fields are, but it should actually be a source to, if you could convert these factors, you would have a chance to see if I can predict, based on Sentinel-2, what that field has in terms of B1 or B2 or whatever soil factor you can measure from the multispectral camera, can actually correlate that on Sentinel-1 and get all the days with a full cloud cover, because the Sentinel-1 doesn't care about the cloud cover. It's just as, if it's a lot of rain, then we have a problem. But if it's a cloud cover, 2017 was actually a very cloudy year. I have another example a bit later, and I have to talk a bit fast now, where we had a farmer where we tried to find a cloud-free day. I couldn't for a 2-month period. So we were not able to find it with the Sentinel-1. Then I tried for the Landsat from American, didn't find one either. Then I went to the Planet Lab that has 200 satellites flying around. They had one image for a 2-month period where there was a cloud-free day. Just to put up how annoying that can be in terms of not getting measurements.
Don't have a holiday at Fyn.
No. Okay. But basically, yeah, and again for the vegetation, they have a lot of indexes here. I'm not completely into what all of these means, but they made it so we could actually pre-process based on that. Yeah. De her den der ej,
Yeah, the WDVI, yeah.
They have a lot of different indexes that they actually said, okay, this is what they have validated somewhere that Sentinel-2 is actually good at predicting. So that's why it's a standard function. And that was why I'm just showing what they actually have in there, because some of those it might actually be possible to correlate some of those factors to the Sentinel-1. I don't think it's all of them, and sometimes there's some in the literature that's claiming they can do something that I haven't been able to reproduce. But
where's this? Where do you get all this? Both the data from the satellite and also the software to.
That's basically from the ESA homepage. You can basically download this. But the challenge is
So the software is called Snap.
Snap, yes. And the reason why I chose to actually do what Snap is doing, but just find standard pipelines. Okay, this seems to be a way they always is doing it in agriculture, because if I was doing the radar, I was looking into the forums and 80% of people were actually doing this exact same thing. I was like, why does everybody has to press a button, process the same thing, and get the same result out? That's kind of stupid. Why is this not pre-processed? And it was actually this, it was actually this January that ESA actually was discovering, okay, it's actually a good idea that we actually pre-process the data a bit more, because if you go into a lot of the menus here, when I started out, I was like, okay, what does this function do? I have no idea. I have no experience in what they were doing. But if you have a standard procedure for, okay, we go through all of these steps, why not present the data? Why should everyone redo and redo and redo? So that's what their software is basically doing. To put up an example, if the area I showed in the start, Rasmus was actually asking me to calculate that. If I had to pre-process that on my own computer for a whole season, that would take, when I start Monday, then I would probably finish Friday. If you ask for it from the server right now, it will take maybe 3 or 4 hours, then you have an answer, because the data is already pre-processed. Why should everyone have to download the data and sit and wait for the data and then do a next analysis? It just takes too much time. It's wrong in my head. But a bit back to this, they have software that's trying to predict where the clouds are, but as you see, the red area is where it's actually perceiving that the clouds are, and if I try to extract that, again a small example here, then you see there are still small parts, if you look at the RGB image, but there's still clouds left. And that's kind of annoying. And again, the same thing here. It's not perfect. But what's relevant to know here is what's going to be on the server is the examples that has low percentage of clouds. And a lot of these examples, if you see them, it's easy to go into QGIS, mark an area out, and actually delete them completely. Say, I don't want to look at this area because there are still clouds remaining. You can actually extract more of the information. It's quite visible that I need to cut out this area and don't look at it, because there's either shadows from the clouds or there's still cloud parts missing. But it still gives you an idea of where there's clouds in the system, and there's also clouds sometimes you cannot see in the RGB, but in some of the other bands, and it's still nice that it's able to filter some of that out. So it's still a valuable tool.
So Martin, my question, when I arrived this morning where we met,
Yes.
corridor, this software, Snap,
Yes.
where I would be able to get daily visibility of my field plot or my fields.
No.
No.
Okay. What you basically have is that if you're not using the service that we put up now, if you want to do this completely by yourself, you will go into the Copernicus homepage and download the product first. Then you would download the software, load pre-processes. You need to actually know a bit about code because you need to compile a number of pieces, and that was why I'm doing it. Because I had to, there is a configuration file, and it was like, Michael, or why should people that doesn't have a background in this sit down and learn programming to analyze a field? It's kind of stupid. So sorry for saying it in that way, but basically I couldn't understand why they were not giving more available.
It's just that you said that they came up with this in general with the at least pre-processed data.
Well, they just concluded they had to do something about it.
No, okay. So
They haven't done anything yet. There is a number of services that's trying to do something, but I'm shocked that nobody's actually trying to.
I think it's also because there are companies that are making a living out of this. I mean, for example, the cropset.dk. There's a company, I think, in Romania where
Sure. There's a lot of
who's
companies
actually making files for cropset every time that they have an algorithm or software that is actually excluding or extracting the fields that are free of clouds. And if I'm in the western part of Jutland, there might be one date in May where it's cloud-free, where it's not cloud-free in the eastern Jutland, and then all fields in the eastern Jutland will not be able to make an application mapping cropset for May.
So we might be a bit over time. I hope that's okay.
Yeah.
Or okay.
It's also my fault.
No. But it's better that you ask the questions. It's better that you actually ask the questions because I think that clarifies for everyone what we're talking about here. But
so Michael, I think it's of course a valid point that companies should earn money, but at the moment it's also blocking for research because we have to buy our way into all these companies.
Yeah.
And another thing, I think it's fair that you actually are doing, you're earning money at some of them, but that's why I was kind of looking for a service for researchers. So if you got a result, you could actually put it out in one of the companies, so they could make a service for the farmers. This should not be a service for the farmers, for them to do an analysis by themselves. This was more for making the data more available for researchers in this area, and then they could collaborate. Then the researchers could collaborate with the companies about making their results into products, because there's a gap there. And if the companies don't provide a service like this, but we kind of need like a common platform so we can kind of redo the same thing again and again and again. So one of the things that me and Rasmus actually did was we contacted a company called Rasmus found it through.
I was to Septu.
Yeah, Septu was actually found that one, and I went into the homepage to see what are they actually doing with this radar data, because I was kind of curious. Because there was a lot of companies out there that claimed they could do a lot of stuff, but he had one. He was saying I could do my extended vegetation in radar-based vegetation indexed, and it should be similar to NDVI. I was like, okay, based on the literature, you shouldn't be able to do that. You would need, from the Sentinel-1, you would need the HH and the HV band, and you don't have that. So what is he actually doing? That became interesting. And one of the things we did, we chose a farmer because we were already working on that area. And one of the things we should have done was we probably should have chosen an area that was a bit more cloud-free. but that was in hindsight. But we still learned a lot because we gave him an 8, and we gave him the information about what kind of crops. He actually asked for that because I was interested. What kind of information do he need to tell me something? because I can learn a lot from what he's and I didn't tell him that I was researching this area. I was just, we are interested in seeing what we can learn from radar. So what can you provide us with? We have people that's flying around with drones, and we want to go out and sample specific areas for doing that. So that was my approach to him. I was not trying to cheat him or anything. We basically wanted to pay him for it. We asked for a specific price.
We paid quite a lot of money.
Yeah, we paid quite a... I was falling down from the chair because we only got one scan here. And if we wanted a whole year, I was like, okay, I'm going to quit my job because I just need two customers, two customers. Then I have a half year salary.
Quit your job and not being a precision farmer.
Yeah, I was like, okay, then I'm just going to sit on my chair and do nothing the rest of the time or what? No, but it was like a silly amount.
But that's also an argument for, you say the company should earn money, but when they want 3,000 euro for a growth season for one farm, come on.
3,000 euro?
Yeah.
That's not bad.
Oh, that's for one field.
No.
Else I wouldn't be able to earn my payment. But it was like an extreme amount. I think that I can't remember what you paid for that, but it doesn't matter that much. But what was interesting, based on what you could see, was he gave us this plot, and it was a bit before the harvest season, and he said, this specific field here is strange. And Rasmus called the farmer, and I don't know if you want to explain that story by yourself.
Yeah, I just called him and asked for if we could get some record of what he has been doing in more details, because there was a strange field. And he was driving his car, and then he just asked, what is the number of the field? And I said it, I said, oh yeah, field. Of course, there was a huge snail attack, so we just reseeded it.
That makes sense, because then we have two different crops in the same field. Mm-hmm. Then every model breaks down. Interesting. So I got one thing from him. I got the date also. I have my data. My next step was actually to go in and see what kind of color label he made here. And what I discovered is that he made his own color range. So it, based on that specific color range, the way he colored it would look like in the eye. That was also an information. Okay, so he has a value range from 1 to 100% that should match in terms of 100 should be 1 in the eye. Okay, and you make your own coloring. You haven't made like from little red to a lot red or a small little green to a lot green. You actually made a color range, and then you have another template for your NDVI that you're coloring in some way, and then you're comparing and seeing, okay, color-wise they're actually looking similar now. Okay, that was information.
Yeah, but you can't do that. I mean,
I'm trying to find out what kind of information he's presenting to me. I'm not saying that it's good or bad. I think
it's typically that it's an index. Every time you're working with application maps and things
Michael,
like that.
try to wait and see the magic.
Sorry.
You have to wait. Okay, we have this specific field here. What I really did, I had the information about the dates. What was a bit puzzling to me when I looked at his plot was, I could see, and this is from the Danish database of they all fly Denmark each one a year, that you actually have areas here where there is trees or gravhøj, I can't remember what that's called in English, stone, where they buy buried the Vikings. I can't remember.
It does pile a lot of soil on top.
They can't put any crops there. What puzzled me a bit was it still had a high color, so like there was growing something. Okay, so it's not perfect, and the pixel size he had, it was 20 meters by 20 meters. Okay, that's also an information for me, because he's probably either meaning his data or he's having he's using a bit of a different process inside. But let's see what we can learn from that. So what I basically did, I just grabbed the exact same image from the ESA server and then I just processed it. And if you look at it, you will actually see that these are the NDVI fields he has. These are the window width fields. This area also looks strange in my plot. Okay, so we're actually looking at the same data. Okay, what is he actually doing? I added the field info and then I just took a big area out here and I just extracted all the window width fields. Then I went in and based on a bit of looking through the three bands, I found out, okay, there was band 1 that was the one that seems to pop out the way he was actually doing it. Interesting. What is he doing? Well, I just extracted the fields for that single band, and then it looked like this. I also took all the surrounding ones, and then I checked, okay, it still matches, it's still somewhat good. I kept my 10 meter resolution because I wanted to see how far I could get to that just. So the assumption is that our processing method is not exactly the same, so there will be noise in the data I will get. I add sample points and I take the field data, so I get sample points inside, so I'm able to sample all the GIS TIFF files he has, and I'm able to sample my own GeoTIFF files and get the exact same value that's underneath it, so I actually am able to correlate two different values now. The exact same, if I had a Sentinel-2 map, I could take the extracted values. So now I have this area. This is the area I want to sample. When I extracted his data and I looked at the band, that was the band 1 from my system, and his ESCEI, you were seeing it was a liner tendency. There was a noise on it, and the way I expected this, that was because he had a bit of a different processing way. I fitted that curve onto it, and then I reverse engineered what he was doing. And I got all the other fields. Now I have his system based on all the other fields, and I can do that basically for all of Denmark, with an exception. I don't know if his model inside somewhere has an impact on incidence angle. I don't know. I don't really know how it works for this small area right now, but it just shows how easy it is to reverse engineer a product somebody else has developed very, very fast. We paid a bit of a price for this, but now we can actually do this for, assumingly, for the rest of Denmark. If his model is not impacted based on incident angle, if it had an impact on that, what I basically just would need would be a place far, far away where the incidence angle was different. Then I would again be able to reverse engineer his product.
What kind of service was he also providing with this 0 to 100, this index from 0 to 100? When he said to you, this one field looks very strange, and the other fields might have looked good, but good for what?
Yeah.
What other services did he actually sell with this?
This was the main service he was selling, based on what me and Rasmus could find out. I wrote to him that we wanted to go out and find places in the field that was interesting to look at. Yeah. And that was, in my head, places where there's variation that does not fit the normal standard. But basically, this is his result. Remember, his pixel size is doubled, and this is my result now.
Yeah.
I also tried one thing because I was saying, okay, maybe someone's going to claim that his pixels are a bit higher. Well, that's just one parameter I'm going to tune up. And then we have that. I was so surprised that the model he was using was so simple. Because I was kind of expecting when we pay so much money for it, the model should actually be more complex. There should actually be something more into it. And I was still a bit surprised, which we can't validate right now because it was so cloud covered for that area. We know there's a satellite that has an image that can do it from Planet Labs. It just takes me a bit of time to get that, and I haven't been able to do that yet. So we haven't actually been able to validate how precise his results are compared to real NDVI from a multispectral camera. But he's actually able to see something. But that's also what I've concluded in some of the early examples.
You can see something.
Yes. Yes.
Yeah, but it seems to be related to reality.
Yeah.
Yes.
That seems to be a very, very nice tool if we can, for modeling the growth and development of the crop.
Yeah, but also, the way I see it is, you have this opportunity to use it. You get data from the fields with a delay of 3 days where you can download after they record it from the server, process it, and go out and see if the same tendency, like I showed in the start, is actually still present.
So you're saying that it's actually 12 plus 3 days, it's 15 days in total from the satellite have been here. No, sorry, from the satellite have, that can be, it can actually, from the last time it was here.
Yes.
Okay, it will still be 12 days.
There's only a 3
But
days.
then you have to add from the, in the
If you
real
want,
time.
yeah, if you want to have, if you saw an event in a data set, and you want to see if that event still is present 12 days later for the same configuration, yes, it will take you 16 days to actually get that answer. Because there is that delay. You can diminish that delay because there's people that's getting the data in another pipeline. I haven't focused on that because I'm seeing this as a research tool right now, and I'm not trying to optimize that part. 3 days delay is in my world fantastic compared to where we come from.
But the other service you could perhaps imagine was that due to all these cloud problems, if you can just pinpoint places with no clouds, calibrate a model from all these holes in the clouds, and then go in under the clouds.
Yes.
Then we have a lot more information than having nothing at the moment.
I agree, but basically my conclusion is, and I'm going to go back to that, is that's the next experiment I did myself, was that he's probably not measuring something that's completely correlated to NDVI. He is measuring something that has to do with the crop, but it's something similar, but you can't, there's no complete correlation between the two. And I'll explain why. Basically, I did a bit of research more, and basically the literature says there's two different approaches to it. There is the ones that does RVI or NDVI or any of those that has large data sets for large areas, and they are claiming that you need the HH and the HV bands to actually predict RVI and NDVI for it to work. It was a bit busy here in the start yesterday, so I haven't gotten that example, but it's out there. There is researchers that only has 500 samples for a small area that's actually claiming they can do it with the Sentinel-1. But in my view, something that you can correlate to so small data set, when you have data set for all of them, from all of the world, that's not a good approach. We need to look at the grand scale to actually see that we are able to predict this. So it's not localized. It actually works on a larger scale. That actually means that I actually took out and created an NDVI map, and that's actually one with the clouds popping before. I just in QGIS just cut out, and I know what it looks like, but anyway, I just cut out all the areas manually, very fast, where there was clouds besides the masking, and went through it. I was very it was kind of a brute force way because I was only interested in areas that were completely sure I could get a pure NDVI measurement or some other measurement. It doesn't actually matter in this case. So the literature is saying big data sets says we can do it based on the Sentinel-1. Small data sets is saying we can. So let's try to find out what's actually the truth. So what I did, I have the field data, so I know where the window width feeds are. I can extract them. I have my VH and my VD bands. That's compared to the small data sets that's claiming it works. They're using those two bands. Remember, again, you could both have these as sigma, gamma, and beta. I'm using the sigma versions for this because that's what they actually did in that article I found. So I'm basically just trying to reproduce the results. Okay, I have a huge number of fields here. I chose all the window reach fields that was over 15 hectares because I wanted big fields. And then I took 1/3 was the test samples.
Så lige marker jo ikke med.
2/3 is my evaluation. And 2/3 is my evaluation set. So I'm just extracting a part of it. My idea was here to see, can I use one part and predict what the others actually should have been, so I have this kind of valuation. So the first thing I actually did was extract the fields from the test set and kind of did the same procedure that I did with his small data set, as you saw before, and just tried to plot to see what would be the result, and this was actually what I was seeing. And in the VI scale here, I scaled it up to 100 just to make it a bit more visible, but it seemed like all the measurements was all over the place.
Yeah.
And I was like, I can't, there's no tendency. There's absolutely no tendency in what you're seeing. I have over 1 million data points there, so I can't see a taking tendency here, sorry. So the next thing I did was, okay, I can't see the data value here, but what I can see, I can try to cluster it. So we start out with values that's NDVI 1.0 and just goes upwards, try to cluster it. Is there some kind of clustering tendency I can cluster in to see if there is a tendency? And my answer was no. No, there is no tendency in this. Okay. So I wasn't discouraged yet, because what I just did was I just tried to get the general tendencies. What if I'm a bit more picky about it? And instead of just taking big fields, but also taking, we found out that a lot of farmers are, when they're drawing their fields, they are drawing kind of strong, wrong shapes inside. And maybe some of the fields I had now was actually sampling outside the area, because I was looking at this very, very huge data sets. So let's try to diminish the data set to see if I can find a tendency then.
What date of year, or what time of year are we talking about?
We are talking about.
Was it end of May? Or?
Yeah, it was. I think it was the middle of May. So I had a talk with Rasmus, and he was saying, okay, is there a tendency? This is just an example. This last one I'm showing here is that you don't find the tendency all the time. Trust me, I've done a lot of failed experiments where I found out, okay, I can't do this. Oh wait, next experiment. So just to show that it can be really, really frustrating. What are we doing? But what I basically did now was saying, okay, let's try to diminish this to even bigger fields. And the next thing was also, I put a lot of checks into the system, so we are zooming in on the center area of the fields and going for that. So now we're only looking at these fields that you see in here, but it's actually throwing out the ones where it has areas where there's strange shapes, and only using very nice ones as a sample area. I have a number of, so I get down to having, I think it's 300 fields for all of that area. And this is basically where I left off. I missed to do the last presentation page here, but anyway, I'll show it. We started to see that there was a bit of a tendency in this. but it's not something. In my world, I'm not sure if Rasmus is satisfied, but I was not happy still. There's a tendency.
The problem is that you don't really know what you're measuring with the radar.
You definitely don't know what the fuck you're measuring with NDVI. And that's the problem.
You have two problems here. You have two problems here. You have that we are actually not.
When you go about 2, leaf area index 2, then NDVI start to get saturated.
Yeah, I know that. Yeah.
So we are measuring something which is getting saturated, related to something which is not getting saturated, the radar.
Mm.
So an NDVI is very good when the radar is bad, because that's relatively termed. NDVI is better when they have a low NDVI compared to radars. Then you're measuring on soil and water and all that stuff. So we are trying to mix two different indices.
But my feeling is that the radar is also being confused by the moisture, and if there are too much bare soil, then the radar outputs some sort of value, and when there is a crop covering the whole area, then it's the moisture of the crop.
If you remove radar for that sentence and switch it with NDVI, it will be exactly the same.
Yeah.
People just forget it. We have 1600 years almost of publications saying NDVI is not the best index. Because of, if you have a dry soil,
I'll just go out and get my other computer. I have the example.
Then it messes it all up. And I think it's amazing that we have so many scientists, companies, all using NDVI, even though there's so much literature saying there's indices, which is a lot more like red edge, inflection point, robust, at least to the soil condition, and it's not getting saturated to the same extent. And I think it's, I don't know, I think it's a mystery for me. Everybody comes out into the door and say, now I want to do research, and they take NDVI. What happened? What's happening? Even from Forum and Explore and all this stuff, they have published a lot of papers saying that there's other indices which is better. I don't know. It's not my field anymore, but apparently everybody's using NDVI like idiots still. And if it goes to YouTube,
at least when you know, because they use NDVI when the crop is at growth stage 32 to 34 when they do fertilization, and that's where NDVI is okay.
If the soil has the same moisture, if you have a very dry,
but the crop is.
If it's covering, yes.
Yeah, it is at that time when we're talking about cereals and rapeseed and other crops. So you're only using it within this limited window of crop growth, and then it's fine. I think that's why there are so many using NDVI. And also because you can buy off the shelves.
I will still question it.
Yeah.
Because if you have a stress crop and you start to get yellowish,
at least it has been
that one.
It has been proven that you can easily see the difference between a cereal plant that has an deficiency compared to one that is fully.
I can take the exactly same field and stress it with sulfurs, and you cannot see the difference.
No, that's
a problem. That everything, and that's what I always say when you ask a plant how are you feeling, you can either say I'm full or I'm hungry. No matter if it's phosphorus or it's sulfurous or it's manganese or it's water, it can only say I'm hungry.
Yeah.
Come on, be a little more. It's almost like EM38 measurements. It can only say, but it's a mixture of clay, salt, water.
And water.
Yeah, it's a valuable tool to look for variation, but you really have to remember the weaknesses.
Not the absolute value.
No.
Okay, but anyway, when we did that extra processing, it seemed like there was a bit of a tendency. It was not like, I haven't gotten that graph, but in this case you just have to trust me, that there seemed to be a bit of a tendency. So we have a tool I use sometimes, and a few of the others also use it. It is a tool that can actually find the formula for the data. It's actually, you just give it raw data and then it finds a formula trying to find the correlation between the data. And it's not linear tendencies, it can be even very unlinear tendencies, it can be differential equations, it will just try to find the solution. And if there's no solution, of course it can't find anything, but it basically tries to come up with the best solution. It has, they called the tool Newtonian because they actually used it to actually show that this tool could actually calculate the differential equation for the pendulum. As you see, they just gave it sample data, how the pendulum was moving, and then it actually derived the differential equation for that, based on that, but just trial and error. They're using a genetic algorithm in the background. So, what this tool basically can, I'm not saying that it worked in this case, but basically I used that one also to test the case you saw before, and if we had a bigger data set that I had been able to validate how it impacted the angle. I have in this case the VV, the VH, and two different angles. And the two angles have those are both incident angles. I chose to calculate both the incident angle where it hit the ground, but also the incident angle compared to the digital elevation model. How do it? Because I couldn't judge which one of them would actually have an impact. So I just gave it all the parameters. I didn't tell it what kind of system it was. The only thing I was telling it at that exact same point, then what was then the NDVI value. Okay. I defined my search. It's still running in this case, we can stop it. But anyway, just go in and say, I assume in this case that it's a standard function. I want it to be able to use constants, integrals, and subtraction, a lot of all standard calculation. Okay, one thing I know is that we have with an angle to do, so problem sines and cosines would be a good idea. It's just an assumption I have, and there's a lot of other terms down there. Just allows it to use. I tell these are the mathematical operations that you can use to try to solve this problem. Then you have what's called start search, and it's running what's basically called, it's trying to minimize the general, for this big data set, it's trying to minimize the general error. And that's why it's called normally if you have, like, for a linear curve, you have the better the R1 value, you have the more linear the system is, but in this case we are trying to minimize, so the smaller the fit value is between 1 and 0, the better result we have. As you see here, it starts out with a value a long time ago, and then it tries, basically tries different combinations, and then gets a new result and just attempts. It can't promise you that it will find a result, but it just tries to experiment, and it says, congratulations, if we have a value below, normally for me, 0.5, then I accept it as a good result, because there's always noisy data. But we won't get that in this case.
Isn't it 0.05?
No. This is actually the best result that I could come up with. This is the fit, and in this case it's 0.8, and that's not good.
No.
But if I look at the error it has, in this case we had what kind of NDVI value you have on the x-axis, and what kind of, if we're trying to predict that one based on the other 4 parameters, what is the error? As you see, you have the size here for this system, and it is quite big. But you also have candidates down here that's not as good, but that's smaller. So it has a tendency to try to find the smallest equation that it can, but if I want something bigger, then it also gives me that option. So it's a very nice research tool to dig into data. This is, as you see, a trial account right now, but in most cases when researchers need something like this, it is enough to have 30 days to just play around to get an idea if this is something we should invest in. But then again, you see residual error is linear actually. But this is actually the best offer that it could give me for this range. what I talked to Rasmus about is that the trainings that we should give it, I think I actually understood him after a bit of a while, was that we need more lower NDVI values and we need more higher values, and we need them more evenly distributed because they are clustered together right now.
Yeah.
So we can't actually evaluate based on this 100% that this is not an option, but based on literature, we shouldn't be able to do it. And this is somewhat also telling me that it's not an option. The ones that are doing the small data sets, I think they're able to correlate nearly anything. But if you're looking at the broader scheme, this should actually work on a large scale. We're talking remote sensing here. It should work for all of Denmark. It should not work for this specific field, for this specific year, for this specific month. It should work all the time.
That's a problem with NDVI.
Yeah.
It works with that exact stress if there's nothing else.
But basically, what they actually show is that they have this radar vegetation index that can show that it's actually very nicely correlated to NDVI, but we're not able to produce that with the Sentinel-1. You can do that with some of the other radars. But this was actually a way, what I think is very valuable, to actually say, there's somebody who's actually producing results here that's not actually, in my view, correct. I might be doing something wrong, but if I put out my approach, which I think they actually missing, somebody is actually able to tell me what I'm doing wrong.
Hopefully they will kill you, so we have
because either you have to tell me what I'm doing wrong, or you have to keep silent, and then my statements kind of still standing out there that I have not been able to measure that. It's kind of the basis for all research that we are able to either falsify what somebody else did. I cannot recreate his result, or the other end, actually verify and get this emerging truths that yes, we actually, oh my god, it's actually the same thing. We got the same result, but both are actually equally valid in my head, because I've seen so many articles where people are claiming they can get something to work, and if you try it yourself, you can't get it to work. And when we have this kind of remote sensing, we can redo the same experiment precisely the same way they did it. So we should be able to get the same result. There's no external parameters if I have the same data set. If I look at the exact same field, I should be able to get the same result. If I can't do that, then there's something wrong.
But if I'm a reviewer on such a paper, on this kind of, then I will always ask for some sort of ground truth.
Yeah, but that's happening something magic then, because there's really a lot of publications where you cannot do it. And Martin has been trawling the net for finding something.
Basically, because we didn't have this kind of reference data, I've used a lot of time on crawling the internet to actually, OnFarm, that was actually by accident. I saw a news from Technological Institute. I've been sitting down and searching for sample data sets, examples on what are you doing. And I think it's valid to actually present. We have the row sets here. They are actually publicly available. Go out, validate that my results are correct. You have the option here. There's something wrong in research if people are not able to reproduce a result.
Yeah, that's the basic.
But it seems like it has been forgotten somewhere when it comes to this, and to some regards also deep learning. All these neural network stuff. They publish, but they don't publish data so you can validate that it's possible.
But basically, it was also to kind of show one of the tools I use to kind of doing exploration inside a data set, to not just look at the data and say it doesn't work. If the computer can't find, based on this kind of approach, can't find an approach either, and I'm trying to give them all the free degrees of freedom and all the data I can, what I would expect it would be relevant. If it can't find it for the scan that's actually taken, the thing is 3 hours in between the NDVI one and the radar one, and it can't find a correlation, then there's something wrong in my head.
But have you found literature that is actually comparing NDVI and radar?
Yes.
Yeah.
No, trust me.
But
Is
is it satellite radar or
it's the Sentinel-1 radar they are comparing it to, and there's articles out there that's claiming they can predict nearly anything with that, and that's insane in my head. There is another Indian article. They basically is able to predict everything on a crop, and I can't reproduce any of it, mainly because I don't have the reference data set. But even on the parameters, I could reproduce, like the ones I could get from Sentinel-2, I can't get to match up.
Because I'm not. I also read some of these papers where they use RVI and NDVI, and they compared all these WBDI and red inflection point and all this stuff. But it's all something that is ground truth.
Yes.
They have been measuring on a certain area where they have control of things. And then what they do later on for these particular 5 or 6 fields, they're doing, as you are doing, either the K-means clustering or the fuzzy seed clustering, and then they're making this comparison of the areas and say that, okay, the NDVI found also this area that correlates with the RVI and this kind of stuff, but it's more area-wise, larger areas where they take many samples, you could say.
But just to teach you, RVI and NDVI is the same, like it's exactly the same information.
The assumption is the way they have created the RVI radar, the vegetation index, they have actually developed the formula for that one, as I actually showed in one of the presentation slides. They have developed it so it actually matches NDVI.
Yeah, that's right.
The problem is we don't have those polarizations, and then it doesn't make sense that somebody's claiming that it works.
I'm just saying that the way you are comparing or trying to correlate these things, maybe this procedure with the big data approach that you are taking here might be wrong.
It might be. It might be. Problem is, if we don't publish what we did, because right now nobody is actually, or the amount of people who's actually publishing what they did is so few. So I have no idea if I don't publish and say this you can't do this. I'm hoping and begging actually for that somebody's coming and tell me I'm a fucking idiot and you should do it this way. Thank you. That's research.
This with the ground truth article. Are they able to predict them?
Yeah,
what is their conclusion?
That some of these indexes are better than others.
Yes.
Yeah, in that case.
Yeah.
In that case.
In these particular areas, yeah.
Another thing I've talked to Rasmus about is that right now we have developed indexes as red inflection point, NDVI, and other factors. One thing we should actually do is we should take Sentinel-2 and have a yield map, have yield values for an area, and then just take all the bands from the Sentinel-2 and let the software try to find the best correlation. Instead of just going after the bands, be more explorative, look at actually seeing, okay, where is the correlation? Because if we humans are looking at 13 bands, then because we are looking at the data, have a tendency to filter out data that might be relevant, but we can't, because 13 dimensions, this is kind of big in my head. I'm happy with 6, that's kind of my limit. Normally,
I think in exactly that case it could be interesting to add the temporal dimension.
Yes. Exactly.
And if we mix radar and NDVI and Sentinel-2 the right way, then we probably could get a quite robust model.
Actually, this software, because there was a few NDVI measurements, there was actually one for May and one for June. That's 2 scans from Denmark I could accept to get NDVI from Sentinel. 1 or 2 actually in this case, from Denmark, from this year. That's actually too few. But if we had more, one of the factors I could have added in here would be the time. And the software in itself would actually be able to correlate data based on that, the temporal factor also. It will just take longer time the more degrees of freedom, we give it longer
Because
protection.
here, everything about field edges. What is it with the radar? If some trees are covered, if you look at a field boundary, in
Yes.
many cases, especially at Fyn and Eastern Jutland, as you showed, there are many trees and forests and stuff that is covering 2 or 3 meters into the field, and then you're getting an edge effect, and you haven't excluded that in this part.
Why haven't I not excluded that part right now?
He has done.
That was basically what I explained to you at that I did. I basically was very
Remove 50 meters.
Yeah, previously, but not this test.
This test, that's the data set where I'm doing that at. I'm still not able to find the tendency.
So you have excluded how many meters from each?
50 meters all the way around the field.
And no inner boundaries is accepted.
Not 50, not 5,
Like 50, yeah. 50.
50, just to be sure.
Okay.
And
And also for the NDVI and
yes,
everything. Okay.
and
So
all,
that's it.
and beside that, I even tried in this case to increase the pixel size. So I took a mean value, so I get pixel size that was 50 meters. To actually, so it was not noise. I actually tried. There was some kind of tendency. It was not very good, but this is not good enough in my head to be accepted as a result.
I think it would be interesting to see if we can balance this a little more so we get like this.
But anyway, it's
Yeah, that's right.
when I looked at this and looked at it and said, basically the way this is happening is because the way the data is distributed and you actually fit a straight line to it.
But I must admit, an NDVI value from 55 to 95 is a huge range if you look at crops.
Yes, it is, but still, we are trying to make a model here. We're trying to make a model that can predict.
But it's fully correctly, as you say, Rasmus, that an NDVI value of 60, is that because of fertilizer or it's because of draft? And if it's draft, then your radar will also have a different value.
I can't remember exact number, but when you're about, I can't remember, 65 or 70, then the NDVI is saturated.
But
so.
if you look at it in this way,
80.
I might be able to create a perfect data set where we might find a correlation.
Yeah.
But the problem is, I might need to have a knowledge about this specific field and how it was.
That's what I mean about ground truth.
But Michael, I'm not finished, and because you interrupted me a few times now. The problem is, if we want to predict what the rest of Denmark is, how it looks like, we don't have that knowledge. So we right now I'm looking for the tendencies where we actually can do that based on a very little knowledge, and this was not one of the cases. There is cases where you can do, for example, with the soil, there is factors where you can actually correlate it and get very nice factors. You're interested in very little knowledge about a field and still being able to predict parameters, not completely precisely, but still being able to do it on a global scale. That would be very, very nice in my head.
Our dream was that we could use Sentinel-1 to get under the clouds.
Yeah.
And apparently it seems to be a little more difficult than just this.
But we can still, there's some results.
Yeah, definitely.
There is results you can get, and you have to say there's stuff you can't get to. You might get to work if you had a lot of more information about this specific field. Then I could create a model. But if we look at farmers in general, how should I, on Danish scale, should I get every farmer to log all the information about his field? Then the purpose is kind of removed from doing this kind of remote sensing. We kind of need to look for the cases where we're able to predict without getting a lot of data from the farmers all the time. Because then we are able to do these general tendencies in the cases where it works. This was not one of them, and that was basically why I wanted to conclude with it. So you don't have this expectation that you just put something in and always get a perfect result. That's not what the satellites are. They give you a good result when you find something and you're able to prove that there is a general tendency. Then they're nice. I think that's